Welcome to Uptime Spotlight, shining light on wind energy's brightest innovators. This is the progress powering tomorrow.
David, welcome to the podcast again.
Yeah, thank you very much. Thanks for having me. It's an exciting event that we're here at, so really looking forward to this.
There is so much happening at Gulf Wind at the minute. Just been watching some of your intellectual property pop out and some of the new things that are at this show. All kinds of areas that you're investing in terms of blade repairs that have been needed for probably 2 or 3 years, and at this point you have good solutions. The one I think we're most interested to hear about is the blade root bushing or insert repair that happens up tower, because everybody's asking about it.
I think that's the important thing there is, first off, we need to get some common language around what this problem is.
Yeah.
So everybody's calling it root bushings, infusion. They're like, what are we actually
What
calling
are the terms?
Yeah,
What
what are the
are
terms?
How do you brand this?
Exactly. Yeah, I mean, just as you say, it's really been a long time coming. It's something we've been involved with now for well over 3 years, and we got introduced originally as an RCA. And so, when you get into something like a root cause analysis, one of the first things you got to do is actually establish the terms you're going to use, establish the definitions, create a common framework that you can communicate around. And so, when it comes to this particular issue, a lot of it really starts with how do customers get sensitized to this? We've seen everything from some customers getting sensitized through, unfortunately, a blade failure, a blade that ends up on the ground.
Yeah.
That's probably the worst scenario. We've seen others where they'll see things like dust on the outside of the gel coat that's starting to build up, gapping, where you have fundamentally a visible gap forming between the blade root and the pitch bearing, where you see visible daylight in some cases. You really want to try and catch things, obviously, much earlier than that, but kind of the common themes here are all around a loss of connection between the metal root bushing and the composite laminate, which caused the blade to become loose from the pitch bearing. So just kind of walk through that system maybe a little bit. You've got the composite blade, which has to transfer load into a metal pitch bearing.
Right.
Metal pitch bearing's got to be able to spin, so the blade can pitch, produce power, and do all the things we need to do. And it's one of the most complicated parts of the blade, really, because you're trying to transfer load from composite to metal, and you have this massive stiffness difference between metal and composites, and so it takes some very clever engineering to bring those two things together and get an even load distribution. And so the way that's done today is through a metal root bushing. So it's essentially a precast metal piece that has geometry to it that allows both a mechanical and a chemical connection between the composite, the metal bushing, the metal stud, which is threaded to the metal bushing, and then that stud goes back to the pitch bearing. You joint all that together with some wedge lock washers and some nuts, and you've got your root connection, really. And that's what's fundamentally breaking down here.
Okay, so the breakdown is occurring where in that assembly? Is it where that bushing meets the composite? Is it the composite itself, the way the composite is sort of wound around that area and how it's strengthened? Or is it that we're pulling on the studs too hard and basically pulling that bushing out of the composite? What creates a scenario where I need to be paying attention to this?
No, absolutely. One thing that's, I think, quite fundamental to this is actually separating damage and defect. And so I'll talk a little bit to the damage, because that's what you're observing when you see this, is the damage that's resulting in this loosening effect. And so fundamentally what's breaking down is that metal bushing with that geometry that's making the physical connection to the composite is fundamentally lost its pre-tension on it. So it relies on both a mechanical connection, so you've got this basically sine wave looking geometry that you've got composite laminate going into those grooves of that sine wave, and you're getting a physical compression joint connection there, and there's a little bit of chemical connection as well. And so as that breaks down over time, you get the composite that's inside those grooves actually forming into a dust and eventually loosening and slowly sliding out.
So is there fiber inside of those grooves, or is it just resin?
That's the goal. So the goal is to have fibers inside of that groove. Basically, if you're going to have a metal bushing and you're going to have composites around it that you want to perform well, you've got to have the right fiber weight fraction, the right combination of fiber and resin in that area to really get the best strength out of it. One key piece there, though, is that we talked earlier about compression strength. And that means that you're relying on the resin strength, which is the weakest part of any composite. And that's really where the challenge is.
So is the issue that we're seeing in the field now, is it from manufacturing incorrectly? Or is it just from wear and tear? Or like, why is this thing rearing its head?
or is it materials?
Yeah, I mean, these are all great questions, and really there's a variety of answers to those questions that are very dependent on which blade type it is, what the fundamental problem is. It really comes down to having a proper root cause analysis or RCA on that particular blade type. And in our experience, it's usually a combination of many things. These blades are incredibly difficult to manufacture. They're complicated. They're incredibly difficult to design. They're incredibly difficult to maintain, and it's really a combination of all three of those things that fundamentally leads to really any problem in this industry. And so to solve it, you've got to have a creative solution, but you also have to be addressing those 3 or 4 different things. And so you really need that proper root cause analysis. I don't know if you're familiar with the 8D kind of process, but having something where you're really trying to look at this holistically and address each of those things you just mentioned and asked about.
What are the first signs that an operator has this issue? Is it just seeing the dust on the outside, or is it something you can hear as it spins, or what's usually that first, like, with the technician?
It's kind of like, put yourself in the shoes of the technicians, the operators who are trying to face this challenge,
right.
Trying to manage risk ultimately, right, is you really don't obviously want your first knowledge of this to be a blade on the ground. You want to catch this earlier. And so just as you said, dust that's forming on the outside is one big telltale sign. The other one is if you've got visible gapping where you put that blade in the 6 o'clock position, technician can go up there, feeler gauge, and measure that gap that's starting to form, do something about it. The other thing is you mentioned audible. You can, in some cases, hear this. You can hear that blade moving, but that's a very, let's call it mature damage. You really want to be catching it before that. Just because you're getting into a risk profile where there's a lot of uncertainty whether or not you're going to catch it in time. And that's really important because we don't want blades on the ground. I think, especially in today's environment, we've got to do right in wins.
So an operator comes to you and says, hey, we believe we have one blade doing this. Is the next step to do NDT work on the whole fleet or on that whole wind farm to understand what the risk actually is to that wind farm, or how does that process move?
Yeah, so really it comes down to understanding that operator's business case, because everybody's going to have a different risk profile. Everybody's going to have a different approach to whether are we trying to repower in a couple years, are we trying to get 20 years and we're only 10 years in? Is this something that's only 2 or 3 years old and we got another 17 years to go? And there's a variety of different solutions. So maybe I'll go through a couple of those if it's helpful. We've seen everything from continuous monitoring systems. There's some great solutions out there when it comes to acoustics, accelerometers, gap sensors. You mentioned UT. We found UT to be quite good when it comes time to actually doing the repair pre and post. And if you want to do a sampling, it's very hard to justify doing UT across tons of
300 blades.
Exactly.
Yeah, it's expensive.
And you really have to have done the due diligence on the front end with UT as well. I think UT it's one of those things that you have to have really approached it in a fundamental way where you understand the defect, you understand what you're looking for, and you've done blind trials to make sure you're not giving false positives or anything like that. So, I don't want to jump straight into the repair just yet, but we can get into that maybe in a minute or two. But one of the key elements that repair is doing a pre-NDT before we go do anything. And that's built into the repair service we offer is we do a pre and post NDT. That's our quality check.
Yeah, if you're gonna get surgery done, you get X-rays or an MRI done before. So so the surgeon knows what he's getting into before you open it up. Same concept.
Exactly right. You got to know what you're getting into. You got to know where you're going, and you really want to, not go in blind. And so, what we've seen is operators will go through and they'll do maybe feeler gauge, dial gauge measurements throughout their farm. That's a low cost, low barrier of entry type measurement that their own technicians can be trained on, and you can kind of have a standardized approach to. Sometimes they'll implement condition monitoring systems to try and again start best utilizing their operation and maintenance fund. How am I going to prioritize if I've got some blades that are really far along, some that aren't? I've got to save some for next summer. CMS really has some great solutions there. But then when it comes time to repair, we do really need to get the UT and get that pre-X-ray, post-X-ray, and go in not blind.
And the bushings that have the most problems tend to be on the leading edge and trailing edge, or that's the 2 areas you need to focus on if you're doing UT?
No, so, it's kind of interesting. It's, again, by blade type, actually. So what we've seen is there's a variety of damages and defects out there. And, you can kind of group it. We group it into kind of static and fatigue. There's stuff that's happening in the first couple years on newer turbines. And there's stuff that's happening in 10 to 12, 13 years on older turbines. And based off of which population those blades sit in, there's going to be a different pattern to where the damage is. So sometimes you see that damage, like you said, in the leading edge, trailing edge. Sometimes you see it over the spars, and sometimes you see it I call it the corners, between the leading edge and the spar cap.
Yeah.
There is a pattern, though. You just have to know what population you're looking in to make sense of that pattern. If you look at it too holistically, you're just going to go, well, they're everywhere. It seems random. But if you know what I'm looking at, it's a fatigue problem. Is this a static problem? Is this a particular blade variant? You're going to start to find those pattern areas. Yeah.
Okay, so then if you generally know what the blade model is, then you know what bushings you're looking for
we
generally.
The whole thing as well. That's the other thing. We actually have pulled in some UT equipment we've been working with now for about 10, 15 years, but comes from aerospace, where this hardware was originally designed to actually NDT blade wings. So it's a very effective, fast way of getting a lot of information around the whole blade root. And so we NDT every bushing on the blade root.
Okay.
And then we can go dial in. We kind of know before we get in there which ones we suspect are going to be problematic, but we want to verify with that with something quantitative.
So what percentage of the blade bushings are going to be bad in like a moderate case that you detect it relatively early? Is it 5? Is it 10? Is it half of them?
Yeah, so I mean, if you're talking about something that maybe, let's say, has 64 bushings on it, you're probably talking 10 to 15. If it's a 90 bushing plus, maybe you're getting into 20 bushings. And again, they're always going to be mirrored. So if you got 10 on this side, you probably have 10 on the other side, that type of a situation.
Okay.
Really.
So the scope of the problem is not as bad as I thought, because I heard operators talk about this saying, well, I got to replace all the inserts. And my first response, that doesn't seem right to me.
Yeah.
But, so the data actually shows it's just certain areas
If
that have
you catch
issues.
it soon enough. So I'll put
Okay,
that caveat
sure.
on there. If you wait too long, it does go progressive. You'll eventually get every single bushing failing, and you'll end up with the blade on the ground and the bushing still up tower. So
And
it's, yeah, unfortunately.
Will it be like the adjacent ones? So if you have 3, 4 of them here, then the next ones to go are the ones adjacent to that, adjacent to that, adjacent to that? Or does it start to show itself in different spots?
No, it's a great question. And what we see is we see that mirroring effect, right? So you see it on each side, and let's say it's centered on a grouping of 3 bushings on each side. That will then start to grow, just as you're saying, kind of this unzipping almost of the blade roots. And eventually, in extreme cases, the other thing we've seen is you'll see the crack where we do what we call turning the corner. So it goes on the outside of the blade, and you see a crack in the gel coat. The first meter and a half of the blade has a gel coat crack, and that crack will have gone through the blade root, through the protrusions, and that's, unfortunately, most likely a scrapped blade at that point.
I've actually seen that up close. So once you start to crack the blade root, is there really a way to recover that? Is that worth even playing around with?
Yeah.
Or is it just like, hey, it's such a repair, it's so intensive, high load area, it's not
I mean, we always say, it comes back to the business case, and I would say most of the time, it's not worth it. All composites can be repaired. There's not a single, you could rebuild the entire blade if you wanted to, but it doesn't make cost sense. And that's really where the business case needs to be brought in. We need to understand, what are you trying to get out of this? Is there available blades? And this is where sometimes there can be some special cause situations where maybe it does make sense to bring that blade down tower, do a very large cut and grind operation, and actually fix these bushings and get that thing back to normal health.
Okay, so the issue is pretty prevalent from what Joel and I have seen.
Yep.
We've talked to a lot of operators that have it. There's a solution now that Gulfwind has developed to repair these bushings up tower, which means no cranes and a lot lower cost. What does that repair look like? Or I need you to walk through it with me, because
absolutely.
I think a lot when I talk to operators, the first thing they say is, well, I don't want to touch it because I got to get a crane. I have to wait till August, when the crane's going to be on site. So it just turns into this big fiasco.
And how, right? We've had this conversation like,
Yeah.
you can fix that up tower. I said that to somebody, they're like, no, you can't. It's like, yeah, you can. No, how? It doesn't make any sense. I'm like, talk to the people that know.
Right.
Yeah, so I mean, we've got a huge passion for composites at Gulfwind Technology. I mean, our history and our legacy has been doing composites, whether it's aerospace, wind, auto bodies, so we love composites. So 3 years ago when we got this problem statement originally, we really wanted to approach it from a fundamental point of view and develop something that was, again, listening to the business case. And immediately we became apparent, you can't bring cranes in, you can't bring this thing down tower, you got to address this up tower, and you've got to do it in a way where you can send a crew up with some bit of kit, some bit of equipment, and get this done in a week or less, really, per blade. Otherwise, again, the business case just doesn't make sense. And so what we've done is we've really developed what I like to call kind of like a laparoscopic surgery almost. So You might be familiar a little bit with the medical industry where you come in, you try and be as minimally invasive as possible, try not to disturb other things that aren't broken. It's kind of the doctor's motto, do no harm, right?
Yeah.
We don't want to go in and just upset all this great fiber that was originally infused in that blade. We don't want to mess any of that up. We've looked at everything from cut and grind to boring bushings out to bringing things on tower. When we were working through the business case, we looked at everything.
Okay.
You could cut the root off and put a new root on, all sorts of, really out there ideas. And really what it came down to is a series of process trials where, again, everything at Gulf Wind, we kind of root in this idea of we build up what's called a process map. We understand the inputs, outputs, we break it down into its critical steps, and we develop a series of critical to quality measurements that we really dial in what does the process need, and then we go run our process trials to dial it in. And the result of all that work over 2 or 3 years is this method in which we go up tower with 3 personnel, 3 technicians, with a piece of equipment that's maybe about 25 pounds or so, a bit of material, and I call it kind of our go box or our go bag. This is kind of kit, about 40 pounds more of material. They go up tower, they're up tower for about 3 to 5 days, execute the repair, and they come back down. So what do they do up tower? That's the question you're really after. Step 1 is we UT, coming back to what we did originally. We do this pre-inspection, get the x-ray, we know what we need to do as far as targeting bushings, that sort of thing, and doing no harm. We don't want to necessarily over-repair. There's no damage if you over-repair. Again, the process has been designed in such a way that you're not going to break anything if you over-repair, but again, it's wasteful. And then we basically are able to get in with this piece of equipment to that interface with very, very minute holes, and basically inject or create quite a significant amount of pressure, almost similar to hydraulic fracturing, and achieve a repair that gets the material into this broken down interface, and we can put a material into that interface with this pump, this equipment, in such a way that we're actually able to purge out any sort of contaminants in there, dust, oil, anything that might be preventing chemical bonding from occurring or preventing proper curing from happening in the adhesive. And we replace the broken material. We replace it with a far superior material that we've developed that, again, it can actually be mixed 1-to-1 with oil. So this material, we've done a lot of lab testing on where we've actually mixed it with 1 part material, 1 part oil to make sure that it can cure properly and not lose strength. But we do purge that out with the material, and we're basically able to get this almost dialysis-like effect through that root bushing and get that cavity back into good shape with this piece of equipment.
What kind of pressure are we talking?
Or
is that secret sauce?
It's a little bit secret sauce, but I would say it's significant amounts of pressure. It has to be very tightly controlled. We've done probably thousands of process trials to dial in that pressure. I would say it's significant. We're talking way in excess of something you would see in an infusion or a vacuum, but it's quite key because we don't want to do any other damage while we're in there. So again, we've developed a lot of very, proprietary methods of actually being able to get that material without damaging the surrounding composite, the composite that's good, and really only attack the bad stuff. It's kind of another analogy in the medical world might be like a root canal. We don't want to go messing up the gums or anything else around the tooth that's still healthy.
Just get that one spot in the tooth.
Exactly, and so it's about pressure, but pressure in the right space. Very similar to hydraulic fracturing in the oil and gas business.
Okay, so you're taking that existing bushing, you're drilling some small holes into it, you're forcing an adhesive up through the interface, the mechanical interface, and then you're going to actually flush out the debris that's inside of this to the front of the blade, the bottom of the blade, or the root of the blade. I guess it's going to come out the front?
No, so we actually...
Or does it just...
Everything is done internal, so nothing is going to be infused into the pitch bearings or anything else. It's all done from the internal side, and it's this dialysis-like effect where we've got a way to bring material in and a way to bring the material out of this cavity and clean everything up. We got good material coming in, and then we basically purge everything out.
Pulling it out on the same side? I mean,
Exactly,
basically, so you have inputs and outputs.
Like a U around the bushing.
Right. Okay, so you're bringing it in, flushing it out, pulling this material out, and at some point you go, okay, the material we're injecting in is coming out, so there's no other debris. We clean this thing out, and then under hydraulic pressure, you disconnect, that adhesive system hardens, and then what?
And so it's got strength well in excess of the material that was originally there. And so what it allows us to do is return both the chemical and the mechanical connection that bushing really needs to perform well. And so that's fundamentally, again, what we're diving into here is trying to return the state of that connection to better than it originally was. And that's what we're ultimately doing with this. And so we've got that material in, it cures, we get to the right spot, we come back in with the UT and we verify that we've done what we said we were going to do. We were going to replace this surface, get the connection back in there, and what we can do is compare pre and post UT and really cement the idea that, look, we know what we did. We can see it, we can prove it, we've got the quantitative data to show it, and we've got a record of it. And that allows us to come back if we want 3 months later, 6 months later, 12 months later and compare. And that's something we've been doing really over the last 12 to 24 months. We've now deployed this quite significantly, I would say, across a variety of turbine OEMs, blade types, different operators. We've done it internationally now as well. So we have quite a strong deployed base, really, where we've got a lot of experience now doing this across a lot of different varieties of hub style, blade type, and we've gone and done follow-ups, right? So anytime we do testing, we start out with doing our coupon testing, all the basics that you're used to. We do subcomponent testing, we do full component testing, and then we do pilot series, fleet leaders, that sort of thing. We've done a huge amount of those over the last, I would say, again, 12 to 24 months, really, where we've then gone back and actually with UT again done a 3-month inspection, 6-month, 12-month inspection to really ensure that we fixed it, but then we're also double checking to make sure there's been no issue. And today we've seen no issue, and that's why we have a lot of confidence where we're at today, is we've got that full testing pyramid really built out from coupons, subcomponent, double lap shears, all the way up through actually proven flight hours, basically, right? At the end of the day, that's what people care about, flight hours.
I think an important thing to touch on here, and you did a little bit ago, is the fact that for a lot of people, they think, I have to replace this blade. So you're thinking crane cost 150, 200, 250,000 bucks for this blade, but you guys are fixing the problem by having a 3-man crew in that blade for 3 to 5 days. I don't know what the cost model looks like, but that's not expensive compared to what we're used to. Like, I've seen 3 to 5 days, people just being inside of a blade fixing a shear web debond or something like that, right? Like, so that cost is something that's not crazy to the industry. It's doable.
No, exactly. And I've got to say a big thank you to our process team. I mean, the process team at Gulfwind Technology has got just decades of experience in process. And what we're really about is trying to take out the complexity of composites, right? We've probably heard at every conference we've been at, it's very hard to manufacture these blades. It's hard to repair these blades. Anytime you're working with wet chemicals, grinding, doing anything like that, it's very complicated and very difficult, very heavy on the human aspect as far as keep maintaining quality.
Science meets art.
Exactly. And so what we really have done is tried to eliminate as many of the variables that are allowing, those sort of errors to creep into the process. And that's what all that stuff about process maps, inputs, outputs, we really fundamentally believe that and try and build that into our process, whether it's the equipment we build and create, the materials we select, the way we drop down our process, the way we do our work instructions. We really want to do it in a way that keeps things simple, keep things easy for the operators. You're not relying on the person with 20, 30 years developed the process, but now the person executing can be somebody that's fairly new to composites maybe, but has experience, has a little bit of training.
So speaking about executing as well, now Gulfwind Technology is taking problem statements in, designing engineering fixes for them, but you're also deploying in the field. So it's your technicians going to the field to do this, correct?
Yes, yeah, so anytime we deploy something, I always say the most difficult part is the RAM, right? A lot of people like to focus on the development and all the testing and the hard work that engineers do to really create a robust product, but the hardest part is actually the ramping part. And so what we've been doing over really the last 12 to 18 months is the ramp. And that means putting our technicians in the field to make sure that we're getting the feedback, understanding the problem statements very early on in the deployment that might be happening, even just simple things like, hey, it's difficult to get this piece of kit through this hatch that's in this particular turbine type, all sorts of things like that, and being able to build that back into how we fundamentally approach doing this process. But, speaking to, models we're looking at, we've, again, everything we do, we try and make it so it can be done in a kit, so it can be FedExed, so it's equipment that can be leased, rented, people that can be trained and certified in the process. But the only way we can do that is first deploying with our crews, build the training material, and that's what we've been doing really over the last 12 months. So where we're at today is we have been starting training of third-party crews, actually. We do have, we've trained 20 people through the training center in New Orleans on this particular process to date. We're going to continue to ramp that and get more people familiar with this process, trained, certified, and basically able to troubleshoot, able to really understand if there's anything going wrong with the process, really trying to build in the robustness from the training side so we can execute this well.
Is there a model in this where you would want to look at blades pre-installation, that that this particular kind of blade is going to have that problem because it's a design issue or manufacturing issue, that you would do this kind of repair on the ground preemptively while it's less expensive to do because the blades are all sitting there? Is that something you've looked at and going forward?
I mean, I think it's extremely dependent on exactly the type of defect and damage that we're talking about with the blade type. So it's something that we would certainly entertain. I think it's very case by case dependent.
True.
Yeah, I would say it's not something we've seen really on the very, very front end of things. Like
Okay.
you do have to generally have something to repair. There's a few, I call them outlier cases out there where you can repair something very early on, but
Right.
For the most part, you need damage to have occurred to have something to repair.
Yeah, I mean, just the discussion with some of the operators that have that issue with a farm and they're repowering with the same equipment, with basically the same blade, and the discussion I've heard is, well, why would I put that blade up if I know I'm going to have this problem? Can I do something on the ground before it goes up so I can just prevent this altogether? It's a lot less expensive to do pre-installation than post.
Yeah, I mean, so I think with the two approaches there, I guess. One of them is I think the timing and the cost model that we've been able to create for this does allow you to do this up tower in a very competitive way, where it actually, to be honest with you, we're pretty agnostic if it's down tower or up tower. It's in some cases, dare I say, actually easier up tower because we can take advantage of the pitch system when we're actually doing the repair.
Yeah.
So kind of funny enough, we in some ways prefer up tower.
Okay.
But
And that's odd.
yeah,
It's not
exactly.
normal. Yeah.
Yeah.
But then coming back to your question about what can you do on the front end, one thing that we've seen a lot of interest in is what I typically call owner's engineering, due diligence, doing factory audits, doing manufacturing inspections, doing firewall audits, all these sorts of things. They're really key. It's important to get experts with eyes on your blades and really do due diligence on things.
Yeah, and that's something that Gulfwind offers, correct? That you will come out and take a look before the blades get installed.
Yes, absolutely. We inspect a lot of blades. We go inside a lot of blades. We do a lot of risk analysis, factory audits. So we've been to a lot of different countries doing these factory audits, and it's something I think that can give a lot of peace of mind. It can help out with financing, getting tax equity financing, working with your insurance company. But then ultimately, what it all comes down to, right, is being able to predict what's going to happen with that fleet. I think one thing that we've got to be very careful with in inspections in this industry is what's the value of the inspection? If the inspection has to allow us to predict better the risk and the way we're going to maintain things, so we can't just be doing inspections for inspection's sake. Otherwise, we're just building
Checking
cost
the
in.
box, yeah.
Exactly. So that's a really important thing for us at Gulfwind.
This is really interesting and good technology. I know there's going to be a lot of operators this summer that are going to be implementing it and over the next couple of years because there's thousands of blades with this issue at the minute. So you're going to be pretty busy sending kits out and sending crews out to go address it. What's the next generation looks like? Obviously, Gulfwind is involved in so many different things simultaneously. What are some of the challenges ahead you're trying to deal with?
Yeah, no, absolutely. So I mean, this is one, I'd call it acute issue that we've developed a product for. We're obviously ramping teams, getting training set up, that sort of thing. We also are very set on, maintaining excellence in composites. So that's a huge thing for us. We've got some really exciting stuff that, at some point I'd love to have you all actually back out to the facility so maybe we can get some hands-on with some of these new cutting-edge things that are happening in composites. I think there's some really new manufacturing technology that's potentially ready to be coming out very soon that we could show you all as far as, fundamental changes in how we deal with materials and fusions, all these sorts of things that come in there. I'm going to leave that as a little bit of a teaser. But we also have some really exciting stuff coming up in the performance world. I think everything we've talked about is what I would call reliability engineering, structural engineering, composites, that sort of thing. But we also have some really exciting things coming up in performance with ways of creating lower, basically being able to get better capacity factors out of low wind speed sites, really leveraging some exciting technologies that are going to allow us to expand wind energy. If you look at the map that NREL publishes every year of wind in the United States, you see it's all concentrated basically from the Dakotas to Kansas to Texas, Oklahoma, and kind of everything in between. And that's all the high wind sites, right? And so I think as a country, it's going to be really exciting to see where that goes next as we start focusing on potentially the Southeast market. What does low wind speed look like in America? And I think Gulf Wind's got some really exciting technologies that are coming out with low wind speed where, I think fundamentally had some paradigm shifts in how we can extract power out of these challenging sites that historically have not had wind installed in them. And with data centers going in, the power demand going up. I mean, Louisiana just had a $10 billion investment in data centers. One of the first wind farms installed in the Southeast, and Mississippi just went in. These low wind speed sites are becoming massively critical.
Right, and the population base in the United States is moving to the Southeast, where there's not a lot of renewable energy, but there will need to be over the next 10, 20, 30 years, so we better figure out this problem today. So I know Gulf Wind Technology is in the forefront of that. David, it's so great to have you back on the podcast, and we do need to get back to New Orleans, just not in the summertime.
Yeah, let's go.
It's so hot.
Sometime when it's cooler.
Right, exactly. So thank you for being back on the podcast.
Absolutely. Thanks for having me.